As the last topic, let's consider some interesting examples that include one-to-one relationship and also recursive relationship. For this, here in this slide, we have two tables. One is department table and the other one is employee table. Interestingly, these two tables include not one relationship but three relationships. First, each table, what is the primary key? Department table has its own primary key, department name, and the employee table has its employee number as its primary key. Now, what these three relationships implies? First relationship is pretty general relationship. So a department has one or more employees. So optional, and an employee belongs to one department. So you can see one-to-many relationship here. And now, what is the second relationship? Here, second relationship is a department has one manager, and a person can be manager of only one department. So here, the employee side, it is mandatory because if there is one department, if you choose one department, you can always find one department manager. However, if you select one employee, this employee can be either manager or not, so it's optional in this department side. And the last one is recursive relationship, and this recursive relationship shows employees have only one boss, and an employee has one boss, and a boss can have many employees. So the employee-boss relationship is a one-to-many relationship. Particularly, it's a recursive relationship since we are using one table for this relationship. Now, further, for each table, let's look at foreign keys. If you look at employee table first, there is foreign key called department name. And why this department name is here, how we generate this department name? When we add first or second relationship? First relationship. So here, this relationship, department has many employees. The one and so department table, the primary key department name is transferred into many and so employee tables foreign key. So we have a department name here. And now in this employee table, we have one more foreign key. And this foreign key says it's a boss number. So when we generate this boss number, it's based on the second? No, actually the third relationship, supervising relationship. So you may recall this relationship when we learned about conceptual modeling. So here, one-to-many relationship, but one side, so one and the primary key is employee number, but this employee number will be transferred into same table in this employee table as the foreign key. So are we going to use the same table name employee number as the foreign key? No, we have to change it, or we have to use a bit more meaningful name. In this case, what we pass here? When we pass a employee number as the foreign key, this foreign key indicates supervisor or boss numbers. So we can change this foreign key name from employee number to boss number. First, since we cannot include two columns with the same name. Second, to make this foreign key as a more meaningful name. Now, in this department table, we have another foreign key called employee numbers, right? So this employee number foreign key, when we generate it, this foreign key is based on the managing relationship. Now at this point, you may wonder why we add a foreign key here. Obviously, if it's one-to-many relationship, we know that one side primary key will be passed as the foreign key like here. But if it's one-to-one side, what is the rule? Which table we have to include the foreign key? So we can, choose either options. The first option is, let's say, here employee number is included as the foreign key. In that case, in this employee number columns, we may enter department manager IDs. If you use, instead of this employee number as the foreign key, if you use a foreign key, additional foreign key in this employee table, and let's say here, instead of department name, it's other foreign key, and let's say it's managing department. In that case, what happens? For some employees who are the manager, we may have a department name that this employee is managing. However, if you have the third foreign key called managing department, there will be many null values for the employees who are not managers. Therefore, which one is better option? Here we included the third foreign key that called managing department, or as shown here, we include the foreign key that indicates manager's employee number. If you compare two options, the option shown here, foreign key employee number in the department table, is better. Since by doing this, we can minimize the null values and we can save the resources in your database. Here in summary, since not every employee manages a department, but each department has a manager, therefore, it makes more sense to store the employee number of the manager. Let's see the actual tables that were implemented based on the design in the previous slide. As you can see in department, we redouble the department, and department name is primary key. And also note that there is employee number column, and why there is employee number column, this is based on the one-to-one relationship, and when it's one-to-one relationship, record foreign key can be added in this department table or employee table. In this case, we implement employee number as the foreign key. So by doing this, this employee number indicates the manager ID, and for each department we have managers. Suppose instead of this employee number, as we explained before, instead of employee number, let's say there is another column, foreign key column, that is managing department name. Then in that case, for employee 51297, so 51297 here, this employee may have matching managing department name, but for other employees, all those values will be null values. Therefore, instead of adding a managing department name in this employee table, the better option is adding employee number column as the foreign key for this specific one-to-one relationship. And now let's look at employee table. In this employee table, we have employee information, and also we have department name, because there is one-to-many relationship. One side the department name is passed as the department for each employee. And also note that there is a post number as well. So post number is a foreign key, but what is the matching primary key? The employee number here is the matching primary key. So for example, when we interpret this table, how can we read this? For example, if I ask who is Sarah's boss, then you may look at Sarah and employee number 8 and read this post number, the foreign key, and you may find employee number 7. So using this foreign key 7, you will go back to this employee table and look up employee number with 7. So here 7 and Briar. So Briar is the boss name of Sarah. So that is how how we use this recursive relationship in this employee table. Since in our database we already have a department and employee tables and all instances populated. This is done when we run a load data script in the previous topics. So I will not recreate those tables, and I will not enter all those informations again. But if you wanna try, you can do it, and I also explained how to do it in your class notes. And in your class note, page 8, there are a few notes. The first note is we talked about deadly embrace. That means when you create a department table and employee table, you know that in department table we have employee number as the manager ID that is foreign key referencing employee table. Therefore, when you create a table, you may want to put some constraint, foreign key constraint for these employee numbers. That means to put that constraint, you have to have an employee table already, since we cannot referencing non-existing tables. So suppose you wanna create an employee table first for this foreign key constraint. Then what happens? When you create the employee table, again in this employee table, you have to add foreign key constraints that is referencing department table as well. So particularly if you read the class notes, there is a foreign key constraint. The name is FK belong department foreign key, and this foreign key is referencing department. So in that case, one table employee is referencing department, but department is referencing also employee table. Therefore, which table we should create first, employee or department? Actually, we cannot if we want to add all the foreign key constraints. This situation is called the deadly embrace. So to resolve this issue, deadly embrace, on purpose, while we create a department table, although we know that employee number is foreign key, we could not add this foreign key constraint as a part of department tables. And another note is when you insert employee informations, note that here for the first employee Alice, we don't have a boss number. Therefore, when you write down insert statement, you cannot just list all the values, but you have to specify the column names that you are entering, and the list of columns may not include the last column boss number. And using these two tables, we will run some practice queries. So at the first practice query, here we wanna ask one question developed based on the one-to-one relationship. So one-to-one relationship is each department has one manager, and here we want to list the salary of each department's boss. So for each department, we have 5 departments, and each department has one manager, and for each manager, each boss, we want to list this employee's first name. So we have 5 names, and each employee, each manager will manage one department: management, marketing, accounting, purchasing, personnel department. And we also want to list the salary for each manager, like this. Then, as I emphasized several times, before you start to design your SQL, you must consider the logic behind your query. So to do this, forget about the SQL, but you may go back to the previous slide here. So here is some example of tables with instances. Then you should think how you can use this information to retrieve both his name and the salary. What you may do is here, department. Yes, I know employee number foreign key is manager's employee number, so I can link this manager number with the employee number, the primary key of the employee table, and I can also find the given employee number, what is the employee's name and the salary. So for example, if it's accounting department, what you can do here, accounting department, who is the manager? Employee number 5. So I have number 5. Then using this 5 foreign key, go to employee table and look at this employee number columns, and where is the 5? 1, 2, 3, 4, 5 here. So what is the this name, my employee's name? Todd. So department, accounting department, Todd is managing. Todd is the boss, and what's the salary of Todd? So Todd's salary is 38,000. So the key is we are using this foreign key, and this foreign key is referencing this employee number, and with this relationship I can retrieve some further information about the employee. So now we understand how to use this given tables. Then it's time to develop the SQL. So for the same logic or same query, there is no unique SQL statement. There could be many variations. So as an example, for this practice query, let me develop two different SQL statements that will give you the same results. So in the server, let me start with without join, how we can retrieve this information. First, we are showing employee first name and department name and the employee salary. So what we are gonna do is we will use the field name in the employee table. So let's consider only employee table, and let's say I can select employee first name and the department. Here department name means which department a employee is assigned. Either he or she is manager or not, each employee has own department name. But we have to check whether this employee is the manager or boss for each department. So to do this, we can use one table after from statement, after from clause. But in this case, we have to add some condition. What's the condition? We don't want to list up all the employees, but we want to list only the boss. So what we can do? We have some restrictions regarding to the employee number. So where employee number is in the list. So how can we make the list? The list of department boss's name is we can select employee number from which table? If you select all the employee number, let me write down here another select statement. If you select employee number from department table, if you are a bit confused, go back to your sample tables. And if you look at the department table, there is a foreign key employee number, and all those numbers, employee numbers, are the list of boss number or department's manager number. So if I have this list, how can I use this list? Yes, we can use a subquery. So here, where this employee number should be in the list of managers. Therefore, one more clause here you need to add is, which one? Yes, in statement. So in. So by running this, what we can get is here I have the list of department boss, and then I can check while we are reading the employee information in the employee table, we can check for each employee whether this employee number is in this list, department boss's list. So if you click go, you can get this result. So each department, you can list the department name and the salary. So we have a 1, 2, 3, 4, 5, department bosses. The other SQL statement we can use. So here, instead of using subquery, another way to get the same result is joining two tables. In that case, we can use two tables simultaneously. So what we can do? First, we can list up all those columns that we want to show. So select which column. Yes, employee first name and employee department name. So employee first name and department name, and let me see. Let me write down department name, and also the last column is we wanna show employee salary. And here the key difference is after from close we wanna use what? Two tables simultaneously instead of a subquery. So to do this, we need some join conditions. But before we consider the join condition, at this point there is one problem. Problem is, if you look at this column, department name, is it clear or ambiguous? It's ambiguous. Why? Because in both tables, both table employee and the department, we have the column name, same column name, department name. So in this case, what we need? We need a qualifier. So what will be the qualifier for this query? We can put the table name, employee table, and dot department name. And what we missed? Although it's one-to-one relationship, we need to link two tables. How can we link? Employee tables, which column? Employee number should be department tables, employee number. So where the join condition is employee tables, employee number should be same as department's tables, employee number. So we can make a join condition. So close it, and if you click go, you will get the same result. The previous subquery is equivalent to this single select statement with a join conditions. So even for one-to-one relationship, we have to include this join condition, and how to make a join by linking this primary key of the employee table with foreign key in the department tables. Now, second query is it's going to be one-to-many relationship, but using the recursive relationship inside one table, employee table, let's find the salary of Nancy's boss. So listen carefully. This recursive query may be pretty challenging and complex. So let's see. Before we start to write down SQL statement, we may go back to this tables, and then we can find the value, the answer, without even considering SQL statement. What is the question here? We want to find the salary of Nancy's boss. So let's see how we can use these tables. So what we are going to do is we may go to employee table first, and using this employee first name column, we will find Nancy. So where is Nancy? Here we found Nancy is employee number 6. We are interested in the salary of Nancy's boss. So in this case, Nancy's salary is 22,000. But we want to find Nancy's boss's salary. So we have to see who is Nancy's boss. So how can you find? Yes, there is one foreign key called boss number. So boss number is foreign key, but what is the matching primary key? In the same table, and the first column employee number. So Nancy's boss's employee number is 5. Now using this 5 as the foreign key, go back to this employee table and scan it. 1, 2, 3, 4, 5 here. So I can see Nancy's boss is has the employee number 5, and his name is Todd, and what is the salary? 38,000. Okay, so here, although we are using two employee instances, one as the boss, one as the employee, one as the kind of general employee like Nancy, but we are looking at physically the same table, employee tables. So let's see how we can develop a SQL statement for what we just did in using these sample tables. So in this SQL query window, think about that. What we are going to show is we want to show employee's name and employee's salary, but we want to compare this with both his name and both his salary. I will start to write down select. Let me show employee first name, and in this example it's Nancy. So Nancy's first name, and then I wanna list first. I wanna find what is Nancy's salary. However, not only Nancy, I wanna know who is the boss of the Nancy. So for the boss, I may still need to use the column name, employee first name. Here you can see already we have some problems. Employee first name, employee first name. Here the first employee first name means employee, so Nancy. But here employee first name means boss. So Nancy's boss name is Todd. So Todd is matched with this employee first name. But how can we differentiate Nancy with Todd? Let's see how we can do it pretty soon. So here now also I wanna show employee salary, but in this case this one is Todd, so the boss is salary, so salary. So in this case now the problem is we are making a join between yes, boss number and the employee number, but we are using the same tables. Just once? No, actually we are using two tables, physically same employee table, but one table as employee, but the other employee table as the boss informations. So in that case, since we are using two two different instances of the physically same table, what we need to do is we have to put some alias, different alias for the same physical table employee. So how can you differentiate these two logical tables like workers and the bosses table? After the physical name of the table, you can name it. What will be the good name? How about worker for the first table, and how about boss for the second table? So just we name it. By doing this, this means after from we use two tables. Physically same table, but logically we are using two different tables, worker table and the boss table. Okay, don't be confused. Then if we put these areas, worker and the boss, now what we can do is after select statement, we can qualify using this alias. So it's pretty interesting. So here the first one is workers employee first name. So instead of physical table name, I can use alias workers employee name, and here the second column is workers employee salary. How about the third column? Now it's boss. So boss is employee name, and here boss is employee salary. So now the one thing we need to do is, yes, physically one employee table, but logically we are linking two tables, logically worker tables and the boss tables. So still we need join condition. How we map these two tables? Don't be confused again. Although I'm here saying two tables, it's logical meanings. So worker tables and the boss tables, we can put a join condition. So for the recursive relationship, for the one physical table but logically two different tables, the join condition again, we need to utilize the alias that we made. So workers, which number? Yes, boss number. So workers boss number is foreign key. And this is matched with, yes, both tables. And what is the primary key for both? It's employee number. So employee number column. This is the join condition. And the last condition is, in addition, we have, yes, workers employee name. So employee first name column is Nancy, but this Nancy employee first name is still ambiguous because we are using logical two tables, worker and boss. So employee first name is boss or employee, a worker. Yes, workers employee first name is Nancy. By combining this, conditions, let's run it. Oh, there is one typo. Let me see. Go back and employee. So employee. Here, if we run it now, I can see Nancy employees salary is 22,000, but who is the boss? Todd. So here, how we can get it? By mapping employees boss number with which one? Here, Todd employees primary key is employee number. So now we can see Todd is the boss of Nancy, and the salary for Todd is 38,000. So I know it's a little bit confusing, complex, but the logic behind this is the same. Since we are using two tables, logically two tables, we have to add a join condition. And still it's one-to-many relationship. However, since the physical table name is the same, we have to use aliases. That's it. So the table name alias is not used just for the recursive relationship. Even not non-recursive relationship, it can be conveniently used. So you may find in your class notes there is one more example. So employee, instead of a table name, we can just simply call it E, or department we can simply call it DA. So that's another example how to use alias for each table. Before we finish this topic, let's run one more practice using a recursive relationship. So here, I want to find the names of employee who earn more than their boss. How we can do that? So what this means? This means if we go back to the original table again, before we develop the SQL statement, in this table, for each employee, I have a boss, right? So for example, here, Andrew, who is the boss? Number 2, Ned. So Andrew, the boss is Ned. And then what we want to compare, whether this employee is Andrew's salary, 25,000, is greater than his boss, Ned's salary. So 45,000. Is it greater than 45,000? No. In that case, I don't want to list up. But for example, here, Sarah, if you look at employee number 8 and Sarah, and Sarah's employee salary is 56,000. And who is the boss of Sarah? Sarah's boss is number 7, Briar. So number 7, Briar's salary is 43,000. So interestingly, in this case, employee's salary number is greater than Briar's salary. So we want to list these cases, this kind of case where employee's salary is greater than boss's salary. So in this SQL window, pretty similar to the previous case. So let me write down this. So select employee first name, but here I want to show worker's first name. But we use same physical table, employee table, in two different ways. So logically, we are using two different tables, workers table and the bosses table. And we have to join them. So how can we join? Where condition is join condition, and we wanna, yes, workers boss number is matched with boss's employee number. So employee numbers, and then another condition is we are comparing two employee salary, workers employee salary is greater than which? Yes, boss's employee salary. So that is the condition. So if we close it, if you click go, you can get the answer. Only Sarah is earning more salaries compared to her boss. So her boss's salary. Okay. So to check this answer is correct or not, it may be useful to run this kind of query. So this query is select everything, and I just want to use two tables, logically two tables, worker table as an alias for the employee and the boss. And if we have only join condition, what is the result? So let's see the result. Here's the result. So we are using employee table two times. First here, employee information, and on the right side you can see there is matching boss information. You can see here boss number is joined with here employee number, and so here the first columns is employee, and the second part here, list of columns, will show the information about the boss. So for example, you may compare net salary here, but who is the net's boss? Alice. So what is Alice's salary here? So you may compare this 45,000 with 75,000, 25,000 with 45,000. So in general, the employee's salary is less than their boss's salary, but there is only one exception. Sarah's salary, 56,000, is greater than the boss's salary, 43,000. So you can easily figure out the expected answer is only Sarah. So we complete topic 4 in module 3, logical design and implementations. In topic 5, the following topic 5, we will apply what we learned in this topic using some different examples. So thank you for listening, and see you soon in the following lectures.